Okay, we're going to be talking about, this is going to be lesson 4 in our unit 6. It's all about parallel and perpendicular lines. And we're going to focus mostly on like mathematically, like in the equation, how can we tell, right? So for starters, obviously, you know what the definition of parallel lines are, right? We have two lines that are never going to touch. We've already gone over that definition, right? We mark them like this, and we use this symbol. We'll call this AB. We'll call this XY. You'd say AB is parallel to XY, right? That's all good and dandy, right? Um, they're going to have the same slope, right? So that's going to be one of the key features. They have the same slope, right? And when we talk about slope, we're talking about m equals my rise over my run. Okay. The difference between parallel lines and perpendicular lines is in the slope. Okay. So again, we already know if we have like a line, we'll call this RS. Oh, sorry, let's use uppercase RS, and this is going to be, oh, that's a terrible. Let's try that again. We'll call this QT. And if I wanted to say that these two are perpendicular, we'd use the upside down T. We say RS. Those two lines are perpendicular. The slopes for perpendicular lines is they're going to be the negative inverse. So negative inverse, let's make this red, keep the all color coordinated. Slopes are negative inverses. Well, what does that mean? That's essentially, we're just making it negative and flipping our slope, right? So flip and negative. Mechanically, that's what you're doing, right? So if my slope for one is rise over run, my other one would be, again, this is not a hard and fast rule. We'd do negative run over rise. You just flip it and make it negative. Okay, you'll see that in the first example. So let's go ahead and do the first example. We want to graph a line that is parallel and perpendicular to the given line, right? So determine the slope of the given line, and then one you graphed in simplest form. Okay, so the original slope, let's just look at the original one, right? So if I'm looking for points that are easy to read, so I'm gonna zoom in, so make it a little easier. Here's a point here, and here's a point here, right? So my original slope would be I'm going up 1, 2, 3, and to the right 2, right? So my rise is 3, my run is 2, so the original would just be 3 over 2. My parallel, because again, they're going to be same slope, is just going to be 3 over 2. So I can draw a line anywhere. So I can make my y-intercept 5, and then I just go up 1, 2, 3, and to the right 1, 2. And so right there, let's go ahead and use a ruler really quick. The parallel line would look something like this. Right? If we wanted something that's perpendicular, right, we're going to take this original slope. Instead of writing 3 over 2, we're now going to flip it and make it negative. Okay? So again, it doesn't matter where we put the y-intercept. We're going to use that slope now. So I'm going to say, let's do, sure, we'll do negative 7. Right? So from that point, I'm going to go down 2, because remember, it's now, my rise now is negative 2. So I'm going to go down 1, 2, and to the right 1, 2, 3. Or remember, we can put the negative at the top or the bottom. It can go up 1, 2, and to the left 1, 2, 3. Either way works. So again, go ahead and draw your line, grab a ruler. Getting pretty close. Whoops. Get rid of the ruler. There's your perpendicular line, right? We'll call this PERPENDICULAR. Right, that's our perpendicular line. Okay, so that's how you determine if they are parallel and perpendicular. We look for the slopes. If they're the same, they're parallel. If they're the negative inverse, they are perpendicular. Okay, that's example 1. Let's jump to example 2 now. We want to find the slope of a line parallel and perpendicular. So we're doing both. We're doing two lines to the line whose equation is 5x plus 6y equals -8, right? So there's a couple different ways we can look at this. Big thing is we need to find our slope, right? So the slope of the original line, because this is in standard form, we can go ahead and switch this to our slope-intercept form, right? And we do that by solving for y. Right? So if I have 5x plus 6y equals -18, I want to get this, I want to get the 6y by itself, so I need to get rid of 5x. Well, we're going to not get rid of, we're going to move 5x to the other side, right? So this is going to end up being 0, and we're going to be left with 6y equals -5x minus 18. Again, we're trying to get the y by itself, so I need to divide everything by 6. So I'm going to take each term and divide it by 6. So we're going to be left with, on the left-hand side, 6 divided by 6 is 1. It goes away. Then we're going to have, I'm going to rewrite this, but it's going to be -5 over 6x. And my y-intercept now is going to be -3, right? Because -18 divided by 6 is -3. Okay, my slope is -6. I can write any line that I want. It doesn't say it has to go through a specific point. So I'm going to say, for my parallel, we have y equals, the important thing is getting the same slope, so -5 over 6, and let's do +5, because 5 is my favorite number, okay? That is the equation for your parallel line. You could have done 0, you could have done 20, you could have done 1,000,000,000, doesn't matter what the y-intercept is. We're just trying to draw a line that is parallel, or write an equation for a line. If I want to do perpendicular, doesn't matter what my y-intercept is, I just want to take my slope, flip it, and make it negative, right? So if I want it, it'd be 6 over 5. Instead of, okay. So all we did was we flipped it, and we want to make that negative. Well, negative times a negative is a positive, so I'm just changing it, right? Or you can just say, hey, I'm getting rid of the negative. We have 6 over 5x. Let's do -2, okay? So there are 2 examples of lines that are parallel and perpendicular. Okay, now we have our last 2 examples. And I forgot to write the multiple choice. So let's just write an equation, okay? So I want you to, we want to write which equation represents a line that is parallel to the line below. Okay, so we need to find the slope. So if I subtract 4x from both sides, we're going to be left with -3y equals -4x plus 15. Divide by -3. So -3 divided by -3 is just going to be y. -4 divided by -3, the negatives are going to go away, but it's still 4 over thirds. We cannot simplify this. And then 15 divided by -3 is going to be a -5, right? That is one example of a parallel line. We could have also said y equals 4/3 x. We could have said y equals 4/3 x plus 30. It doesn't really matter as long as I have that 4/3. Now, if I want to find the equation that represents a perpendicular line, same stuff. Get y by itself because we're in standard form. So we get 4y equals -5x plus 24. Divide everything by 4 because I want to get that y by itself. So we have y equals -5 over 4x plus 6. So if I want to get a perpendicular slope to this, I'm just going to write y equals, flip and change the signs. We have 4 over 5 x plus 2. That would be an example of a perpendicular line. Okay. So the key thing for this lesson is when you have parallel lines, the slopes are the same. When you have perpendicular lines, you're looking to flip and make it negative. All right, that is it. Have a good day.